Makeup data for the friction lab. If you missed the video with Dr. Rochenbach and you weren't here for this part of class, you can just write excused across here, or you're welcome to get that. It's kind of interesting from somebody else in class. I'm going to start the makeup data for this activity number 1, where you test a rough and smooth side of a board. Here you're going to draw, or you're going to tell me what you're seeing, how I set up my experiment right here. Over here you're going to draw a picture of my 2 different experimental designs, and then down here you're going to write how many newtons it took to pull each of those, and I'll say them because you probably won't be able to see it in the video. Okay, so for the first experiment I just put 3 blocks on a piece of wood here. This is the rough side of a piece of wood down here, and I'm going to pull this and read how many newtons it says to pull it. So I'm going to get it going here, and it says about 2 newtons. So actually it looked like 1.8 newtons. 1.8 newtons. And now I'm going to do the same on the smooth side of the board. And it looks like 1 newton. So down here, I reversed those. The rough surface was 1.8 newtons, and the smooth surface 1.0 newtons. Here you would draw or explain the setup that you just saw. Here you would draw my 2 experiments, one for the rough side, one for the smooth side. Okay. And then I'll let you do the summary statement on your own, the real life applications, and then the A quality work block. Experiment 2, heavy mass versus light mass. So the way I'm going to do this is I'm just going to set it up on the rough side here. I'll use no mass to pull the first one. So I'll just have a block without any mass on it. And it looks like 0.2 newtons to pull that. 0.2 newtons. Now I'm going to add some mass and see what happens. That says 1.8 newtons on that one. So for part 2 of your experiment, explain what I just did, draw a picture of no mass over the block, and then I have 3 iron blocks over the other one. And then here's the force needed to pull those, and you can write the numbers I just told you on those, and then you can go through the rest. Next one is on rolling friction versus sliding friction. So the way I'm going to set this up is, well, we can just stick with this. Sliding friction has a number of 1.8. What happens when I set up some wheels, so to speak, to pull it on and retest? I get 0.2 newtons. So here with wheels, I get 0.2 newtons, and over here I had about 1.8 again. And the last experiment right here is I'm setting up some square blocks to show this one. So I'm putting blocks on here and going to pull this and read the number for static friction just before the block lets go. I'm at 3 newtons, 3.2, 3.4, 3.6. I'm at 4 newtons. Wow. There we go. I was at 5.2 newtons, 5.2 newtons. So now I'm going to try it just pulling it and see what it says. Oops, I forgot to keep the blocks on. Sorry. Pull it and get a smooth pull going. This is going to be a little harder to do. There we go. It's about 3.5 newtons as it's being pulled. So that ought to give you some data for your lab.